going to jump into 2.3. Look how much better this video looks. We fixed some things here on campus, and so now it'll be a video directly of my examples and notes. So hopefully you guys are watching. Your grade depends on it. So 2.3 is on savings accounts, mostly about how to calculate simple interest. We're going to be diving into something called compound interest later. So in simple interest is basically the bank pays you interest for keeping your money there. It's a very small amount, but it's free money. So I want to go over a couple basic things before we start. And the first is how to convert a percent to a decimal. Okay, and there are two methods. I'm going to show you both. Okay, there are two methods. One, you can move the decimal. And I should actually move these over. There are two methods. One is to move decimal 2 places to the left. The other method is to multiply percent by 100. So I'm going to do a couple of problems showing you both methods, and you pick which one you prefer. So convert the following. Number 1, 2%. So I'm going to show you both methods. Here's 2%. There is an invisible decimal here, so I would go 1, 2, and in the blank spot I would add a 0, so 0.02. Or I can take 2, whoops, this is not, this should be divide. I'm so sorry. The next method is to take, I have 2%, and I'm going to enter 2 divided by 100 into my calculator. So if you take your calculator out, 2 divided by 100, and I get 0.02. So notice each method gives us the same answer of 0.02. So you pick which method you like best. Maybe you've already done one of these methods before, so you pick whichever works for you. So the next one, 3.265%. Okay, method 1 would be to take that number and move the decimal 2 places to the left, which would give us 0.03265. Okay, or again, you could take whatever they give you and enter it in the calculator and divide by 100. Either method should give you the same answer of 0.03265. So 0.03265. Next one. So if I have 4.5%, no matter which method you use, okay, you can move it, 2 places to the left, or you can divide by 100. Either way, you should get 0.045. Okay. Next, I'm going to go over how to list rates. So if we want to compare, so I'm going to go over how to list interest rates in ascending order. Now, ascending order means you go from low to high. If your homework asked for descending order, that would mean it would be from high to low. Okay, but ascending, you start with the smallest number and you work your way up. So here's an example. 5.51%, 5.5%. So if we were comparing banks, we wanted to know who had a better interest rate, which is one of your homework and test questions. Here's how you would do it. So they've asked us to list interest rates in ascending order. The first thing I have to do is make sure I convert fractions to decimals so that all of these numbers are comparable. So using our calculator, I would take 1/2 and I would convert that to 1 divided by 2, and your calculator would give me 5.5%. And you got to convert 5/8 to a decimal. You would do the same thing, 5 divided by 8, and that would give us 5.40. Oh, I'm sorry, 5.625. Where was I getting 40 from? So if I was to list these in ascending order, you're going to start with the smallest one. So the smallest number I have is 5.099%. And then you can check it off. Then next is 5.5. Then think of that as $5.50. This is 5.51. So check that one off. Then 5.6, because there's an invisible 0 after the 6. And last, 5.625%. Okay, so that is how you would compare percents, convert their fractions to a decimal. All right, moving on is to go over something in your notes or in the book called an arithmetic sequence. And an arithmetic sequence is simply something that has a pattern where it's increasing or decreasing by the same amount. It is increasing or decreasing by the same amount. And they call that amount the common difference. So the rule for an arithmetic sequence, and this is something like an example would be 4, 8, 12, 16, and so on. This is an arithmetic sequence because each term is just plus 4, plus 4, plus 4. You're adding 4 every single time. So an arithmetic sequence is just a pattern of numbers. Now here's the formula that we're going to use. A to the nth term, and notice the n is lower, it's below the line, equals A1 plus n minus 1 times d. Now I'm going to go over their parts. This is the first term. This here is your common difference. And n is the specific term. So we're going to jump right in doing an example so you can understand this better. So number 1, here's a pattern. 211, 223, 235, 247, 259, and those dots are signaling to you that this pattern continues on and on and on. So first part, let's find what is your common difference. And remember, as far as our formula goes, that's the letter D. So I'm simply going to take a calculator and I'm going to subtract my terms. For example, 223 minus 211, what do you get? Or 235 minus 223. Pick any two terms and subtract the one before it. And it should be the same number if this is an arithmetic sequence. So if you take your calculator and you subtract any of these, I got a difference of 12. So D equals 12. Now I want to help you understand n. 211 is my first term, so I would say this is n equals 1. This is this 223 is the second number they wrote, so I would say n equals 2. This is my third term, so n equals 3, n equals 4, n equals 5. N is just referencing what position a number is in your sequence. So if it's second, then n is 2. Okay, and then that would just keep going. So in part B, I'd like you to identify what is the first term, which in our case is A1, and we would say 211. C, find the 10th term. So here's how we would find the 10th term. I'm going to use my formula that I have written above. So when they say 10th term, we're looking for A10. We're looking for the number that's in the spot of the 10th term. Equals A1, our first term, which we identified is 211, plus, notice the formula says n minus 1. Well, that right there is n. So here I'm going to put 10 minus 1. And I'm going to multiply it by D, and we discover D is 12. Now I'm going to simplify this. I'm going to zoom in a little bit. So I have A10 equals 211 plus 9 times 12. And I'm going to simplify that. That's 211 plus 9 times 12 should be 108. So A10 is 319. Okay, so let's move on to the next one. So up above, I didn't circle my answers. Sorry about that. Number 2, an arithmetic sequence has first term 25 and a common difference of 3. Part A, find the 50th term. All right, so let's use our formula. I'm going to move this up. I'm looking for A50, the 50th term. Now, once you write 50, that tells you that that right there is n. N is 50. So I'm going to write my first term, which they told me is 25, plus the formula is n minus 1, so 50 minus 1 times D, which they told me is 3. So that right there is D. That right there is A1. Sorry, this should be a 3, not a D. My apologies. So that equals 25 plus 49 times 3, which I got is 172. So the 50th term, or A subscript 50, is 172. Part B, find the first 4 terms of this sequence. Now, they told me the first term was 25, and they told me the common difference is 3. So I'm simply going to add 3. So the next term is 28. Add 3, 31. Add 3, 34. If D was negative 3, then you would be subtracting. Okay? So now let's do a couple problems that look like the ones in the book. So I'm going to do a couple of these with you. It should look like your homework. So in the book, they give us a formula for simple interest. Simple interest is I equals P times R times T. Okay? P is your principal or your starting deposit. R is your interest rate as a decimal, and T represents time. Okay, so sorry. So here's the formula we're going to use for interest. Okay? So Gary deposits $3,700. So when it says deposits, I should put that up here. Principal is the same as deposit, your initial deposit, your starting deposit. An account that pays 2.15 interest. He keeps the account, the money in the account for 3 years. He doesn't make any deposits or withdrawals. How much interest will he receive? So interest equals his initial deposit times our decimal. Remember, that's why we went over converting our percent to a decimal. So you can either divide by 100 or move the decimal 2 places to the left. And then we're going to multiply that by time, and it's been 3 years. So you're simply going to enter that in your calculator, 3,700 times that, and you should get $238.65. That is money that the bank is going to put into my account for me just leaving my money there. So that's free money. I'll take a free $238 any day. Number 2, how much simple interest is earned on $6,000 times my interest rate of 0.0225 times 4.5 years. 4.5 would be 4.5. So you're simply going to enter that in your calculator. 6,000 times 0.0225 times 4.5, and you should get $607.50. So you can pause my video if you want as we go through this, but these next few ones are super, super important. So the next one, how much principal? So I have no idea what P is. Would you have to deposit in order to earn? Notice they put 700 simple interest. So they're telling me that I equals 700. So that's why I put 700 in the place of I. So I'm looking for P. They tell me my interest rate is 2%, so 0.02, and time is 1.5 years. So using your calculator, you're going to simplify 0.02 times 1.5. And I get 700 equals 0.03 times P. Okay, next, I'm going to divide by 0.03. And I got that P equals, this is how much I should deposit to get that much in interest, $2,333.33. Your answers are in dollars, so it is okay to have decimals. Just make sure it's in cents. Okay, next one. Jesse estimates that it will cost $300,000 to send his newborn son to a private college, 18 years, so there's your time. He currently has $65,000 to deposit. So he has, what simple interest rate would be needed so that $65,000 grows into $300,000? Wow. So I want a total of $300,000. So I am solving for R. So he's asking if I deposit $65,000 now times my rate times 18, how much will be needed in order to have a total of $300,000? So let's talk about the difference here. What's $300,000 minus $65,000? Because he's wanting to earn the difference. So $300,000 minus the deposit of $65,000 leaves me with $235,000. So he's wanting to earn that much money in 18 years. So I'm going to put 235, 1, 2, 3. Okay, and now I can solve this. So I'm going to simplify this equation by multiplying 65,000 times 18. And I'm going to rewrite this. So I have 235 equals 117 and then 4 zeros. And I got that by entering it in the calculator times R. Now I'm going to divide both sides by the number in front of R. And I think I have an extra 0. I do. And so this cancels. So using my calculator, 235 divided by 117 and then 4 zeros. And I got R equals 0.2008. If I want to make that a percent, he would need an account that pays 20% interest, which, by the way, does not exist. Okay. All right, number 5. Dylan has a bank account that pays 3.2%. His balance is $1,766. How long will it take for the amount in the account to grow to $2,000? So again, I'm looking for 2,000 minus the 1,766 would equal what's the difference? Because you're looking for the interest earned, not the total, and that gives me $234. So he's wanting to know how long it's going to take to earn that much in interest. So $234 equals, I have a deposit, or I have the amount in my bank right now is 1,766 times 0.032. And I'm wanting to know T for time. So I'm going to enter this part in my calculator, 1766 times 0.032. And I get 234 equals 56.5 T. I'm going to divide both sides by 56.5. And I get T equals 4.14 years. Okay. All right, how long will it take 5,000 to double in an account that pays 1.6% simple interest? Round to the nearest year. So if I'm wanting the account to double, that means I'm wanting the account to earn, I'm wanting the account to have a total of 10,000, right? Well, 10,000 would only happen if I then added another 5,000. So he's wanting to know how long it will take us to earn $5,000 in interest. So I'm depositing 5,000. I'm only earning 0.016 interest. And I am wanting to know how many years it will take me to earn another 5,000, right? Because that would double the account. So 5,000 times 0.016 gives me 5,000 equals 80 times T. 5,000 divided by 80, and I get T equals 62.5 years. A long time. All right, number 7 I'm going to skip because it's just like the one we did earlier. How much interest would be earned in 275 days? So notice for this one, I'm going to skip 7 because we did a million like it. Well, actually no, because it says 11 months. If it doesn't give you a full year, then you have to convert what part of the year that is. So if I'm wanting to know how much interest is earned on 1,500, it hasn't been an entire year. So how many months are there in a year? Well, they want to know 11 out of, there's a total of 12. So I have to multiply the fraction of the year we're using times our rate of 0.0375. And then you would simply enter all of that into your calculator. So 1,500, parentheses, 11 divided by 12, parentheses, you know what, let me re-enter that. 1,500 times, parentheses, 11 divided by 12 times 0.0375. And I get $51.56. So in almost a year, that's how much you earned in interest. Number 8 is going to look very similar. How much interest is earned if you deposit $1,000 in 275 out of 365 100 days in a year times your interest rate. And then you would simply multiply that. So again, 1,000 times 275 divided by 365 times 0.0421. And I get that your account would only earn $31.72. Notice I let the 9 round the 2 up. Okay? All right, so I'm going to do a couple more problems and then be done. So Colin deposited $12.30 in an account that pays 2.19 simple interest for 3 years. So what will the interest be for 3 years? So I equals 1230 times 3 times 0.0219. If you enter that in your calculator, I got $80.81. What will the new balance be? Okay, well, if he deposited $12.30 and he's earned $80.81, I'm going to add. And if I add that together, he now has $1,310.81. So I'm adding the deposit and the interest earned. How much interest did the account earn for the first year? Now you can do it multiple ways. You could simply divide this by 3, or you could re-enter the equation. So you could do what's the amount he deposited times 1 year times your rate. And I got $26.94. You could have also taken the interest that he earned in 3 years and divided by 3. How much interest did he earn in the second year? Well, it would have been the same. Whoops, that should be 94. And for the next year, the same. All right, so that's pretty much what you'll be doing in this lesson. Thank you.